So good morning. We're going over 2.7. So we're going to go over combining and compositions on functions, part 1. It's sums, difference, products, and quotients. So you have the algebra of functions, which is let f and g be functions with domains a and b. Then the functions of f plus g, f minus g, f times g, or f divided by g are defined as follows. Yeah, f plus g of x, it's the same thing as saying f of x plus g of x. Then you have f minus g of x, the same thing as saying f of x minus g of x. As well as f times g of x is the same thing as saying f of x times g of x. The same as f divided by g of x is the same thing as saying f of x divided by g of x. Why is it the same thing? Because if we were to have distribute that x to both terms, we end up with this. So you can either take out the x and put it to the side, or you can write it together. Now, all of that is just domains from A to B. But you guys know, you guys have been using this. This one means union. Now you're using the one that's upside down. That means intersection. The best thing I usually do for this is, let's say you have a circle for A and a circle for B. Let's do this in blue and the other one in red. Now, what do I mean by that? Your union is the blue one, and then your red one is the intersection. Now, why is that important? You guys are used to union when you're writing domain because we skip the parts that don't intersect with each other or that don't work with each other. So if you have one equation, let's say the domain worked for up to a number, and then from that number to another number doesn't work, and then you keep going for the other side of B, which worked for both. That's what you guys have been doing. They're saying we go from here to here. Now, the intersection is what we're working with, which is the part that doesn't work for either of them, if you think about it in domain. It's just known as union and intersection. Intersection is where they overlap each other. So we have example 1. They want us to let f of x equals 1 over x minus 2 and g of x equals the square root of x. They want us for A to find f plus g, f minus g, f times g, and f over g, and their respective domains. And then they want us to find for B f of g, f plus g of 4, f minus g of 4, f of g of 4, and f of g divided, and then of 4. So I'm going to open a new slide because I don't have enough space to do all of that. So we have, let's do example 1. So we have f of x is 1 over x minus 2, and then we have g of x is equal to root x. The first one is f plus g. So here you would just do exactly what it's telling you, which is to add it. So we're going to do 1 over x minus 2 plus root x. Now, you can, this one, there's nothing we can do to it unless you want to combine them. That means you have to multiply x minus 2 on the root x and then put it over that. But we're good to leave it like this just because there's nothing we can actually do to simplify this. And so we're going to look at the domain. How do we figure out the domain? The domain is going to be, again, stuff that cannot happen. So we equal that bottom part to 0. So it can't equal 0. So our x cannot equal 2. And then we look at the square root of x. We know x cannot be less. So the square root of x cannot be less than or equal to 0. So x has to be greater than or equal to 0. So that's how we're going to choose our domain. Everything is included except x cannot equal to 2. And then x has to be greater than or equal to 0 in order for this to be okay. So everything else is going to be included. So we're just going to write it like this for the time being. So your solution would actually be this thing. You can combine it if you want. You don't have to. And then that domain is this. Now, B, they wanted us to do f minus g. Again, in this case, we cannot combine them. In some cases, we can and we should. But in this one's already pretty simplified. So that would be your solution. And again, the domain would be the same as the first one, just because we cannot have x is equal to 2 and x has to be greater than 0 in order for the square root of x to be a true statement. So that's the answer. And then we're going to get x again is cannot equal to 2. And x has to be greater than or equal to 0. For C, they wanted us to do f times g. So we'd do 1 over x minus 2 times square root of x. We're going to we can't simplify this one, so it's going to end up being root x, x minus 2. And the domain will be the exact same because we cannot equal to 0, so the domain is going to remain the same for pretty much all of these. So the solution would be this combined form, and then x cannot equal to 2, and x is greater than or equal to 0. Now, let's look at, I'm going to do division in a different slide. All right, so for D, let me write the equations up here. We're still in example 1. So for example 1, part D, they're asking us to do f divided by g. So that's going to look as 1 over x minus 2 divided by root x. Now remember, when you're dividing a fraction, remember this is an over 1 statement, so you can always do keep, change, flip. So it would be 1 over x minus 2, change the sign, 1 over root x. So when I combine them, I get a 1 over root x, x minus 2. In this example, I'm going to leave it as a completed note in the sense that you can leave it like this. If you like to rationalize it, you're going to end up with multiplying root x times root x, and you end up with root x, x minus 2, which is the same thing we got before. But for the time being, I'm just going to leave it the same way as the completed notes, so they're consistent. So that will be your solution. And again, since the domain doesn't change, because it's the exact same equation, x has to be greater than or equal to 0, and then x cannot equal to 2. So for now, this is your solution, just to be consistent with the notes. You can rationalize it if you wish, and then you have x is cannot equal to 2, and x is greater than or equal to 0. Now I'm going to rewrite the equations on top anyway, so you guys have them. Right? We have them in every single slide. So they're asking us now for example, it's pretty sure still example 1, yeah. Example 1, part B. What are they asking us? They're asking us to f plus g 4, write that as A, f of g 4. They're asking us to subtract them from 4, multiply them with 4, and divide them with 4. So, how do we do this? If we do the first one, which is f plus g, we're going to do the f. So, I'm going to write them originally the same exact way. But now, since they're asking us with a value of 4 for the x, anytime there's an x, I will plug in number 4, because that is the number that they told us to use. So then it's going to be 1 over 2 plus 2. And then I can actually combine these by multiplying this right equation, this right number, which is a 2, by 2 over 2. So I end up with 1 over 2 plus 4 over 2. So I end up with 5 over 2. So my f plus g to the 4 is going to equal 5 over 2. Like this would be your answer in this case, the 5 over 2. You don't have to write f plus g of 4 equals 5 over 2. I'm doing it so you guys see the full setup. If you just write 5 equals 5 over 2 and you're following the work and it's organized and you mark it and you circle it, then that's fine. Now for B, they're asking for f minus g, again 4. So I'm going to do 1 over x minus 2 minus root x. But again, anytime there's an x, I will plug in this case, the 4, because that is the number that they're asking us to use. It's going to be, again, a half minus 2. So this will become a half minus 4 over 2. So we end up with negative 3 over 2. Just to write it in the full format, it's going to be f minus g of 4 is going to equal negative 3 over 2. So again, let me just rewrite the equation. We have f of x equals 1 over x minus 2, and g of x is equal to root x. So now the third one of example 2 was f times g of the 4th power. So again, I'm just writing in x for the time being, but for every x, I will now substitute a 4. So I end up with a half times 2. Now that's going to simplify to 2 over 2, which equals to 1. So f of g to the 4th is going to be equal to 1. And now for d, they're asking us f divided by g of 4. So I'm going to go ahead and do 1 over x minus 2 divided by root x. Again, I'm plugging in those numbers. 4 and 4. So I end up with a half divided by 2. Again, this is 2 over 1, so I'm going to do keep change flip. So I end up with 1 over 4. So that's going to be f divided by g of 4 equals 1 over 4. That will be your solution for this 8 problems. Well, same problem for different parts. Here we have example 2. They're giving us f of x is negative 2x plus 3, and then g of x 1 over x plus 4. They're asking us to add f plus g of negative 3. So we're going to go ahead and just write it in. So it's going to be negative 2x plus 3 plus 1 over x plus 4. Now, wherever there's an x, I will plug in now a negative 3. That's going to be negative 2, and then negative 3 plus 3 plus 1 over negative 3 plus 4. So that's going to become 6 plus 3 plus 1 over 1. So it's 6 plus 3 plus 1. So that's going to be 9 plus 1, and that gives us 10. So our solution is 10. If you want to write it in the full format, it would be f plus g of negative 3 is equal to 10. Now guys, just so you know, on the completed notes, I made a bit of a mistake. I wrote a minus right here instead of a positive. So just keep that in mind if you use them to study. I made a mistake when writing them in. I just copied the equation wrong. Now they're asking us to do g minus f on the next one of negative 1. Now the order is important, so please just go in the same order as written. So it's going to be 1 over x plus 4 minus f is negative 2x plus 3. I'm going to keep it in a parentheses until I solve it. So wherever there is an x, I will plug now a negative 1. So it's going to be 1 over negative 1 plus 4 minus negative 2x plus 3. Sorry, not x. It's going to be negative 1. Negative 2 times negative 1 plus 3. So that's going to become 1 over 3 minus 2 plus 3. So that's going to be 1 over 3 minus 5. And then I'll rewrite it as 1 over 3 up here. Minus 5. And I can make that into a fraction by multiplying the top and the bottom by 3. So I get 15 over 3. So I'm going to get negative 14 over 3 as my final answer. So if you want to write it in the full format, it would be g minus f of negative 1 equals negative 14 over 3. Now guys, this is another mistake on the completed notes. I put it in the wrong order. I did F minus G. The order does matter because when I did it the other way, I got positive 14 over 3. So just don't make the same mistakes I did. I made a bit on the completed notes for this section. Clearly example 2 for the first one and the second. This is the correct way, which is the order does matter. And I just changed the sign for the first one, but yeah. I'll go ahead and do the third one. So it's going to be F first. So it's going to be negative 2x plus 3 times 1 over x plus 4. Now every time there's an x, like we've been doing, I will plug in a 5. So it's going to be negative 2 times 5 plus 3. And then times 1 over 5 plus 4. That's going to give me negative 10 plus 3, and then 1 over 9. So this would be negative 7 times 1 over 9. And when I plug that in, or I finish it, it's negative 7 over 9. So that would be your final answer, or if you want to write it into the format we've been doing, it's going to look like this. F of G times 5 equals negative 7 over 9. All right, so this one is F divided by G, and then of 2. So it's going to be F first, 2x plus 3 over 1 over x plus 4. Now, usually, remember, we're dividing by a fraction, so that we usually end up with a keep, change, flip. But before you do that, actually, you can write it like this if you want first as well. It's really up to you how you prefer to write it. You can do keep, change, flip here and make it into negative 2x plus 3 times x plus 4 and treat it as a multiplication. Or you can plug in this stuff first and then divide. It's really up to you. Now, all right, so I'm going to do this one. So I'm just going to go ahead and plug in a 2. It'll be negative 2 times 2 plus 3. Then times 2 plus 4. So it's going to become negative 4 plus 3. And then 2 plus 4. This ends up being negative 1 times 6. So I end up with negative 6. So you can say F divided by G times 2 is equal to negative 6. Just so you guys know, in notes, I did use the same way. I just happened to distribute before I plug in the number, which you can by all means do. I would just ended up with a quadratic equation, which at the end, after plugging the numbers in, I ended up with negative 6. I don't know why I did that, to be honest, but you get to the same answer. So you can distribute if you want the exponents. You can plug in the number first and then see how it simplifies. I recommend you guys plugging in the number and see how it simplifies, just because it's a bit easier. The numbers tend to work out faster.